Hey Ramblers! This video covers chapter 8.4 in our textbook and deals with two principles that are really similar to CPCTC from the first semester. You'll recall that once we proved two triangles congruent, we were able to show that the corresponding parts of the triangles were congruent using CPCTC. Well, this semester, in this chapter, while we're dealing with similarity, it's not exactly alike, but it's awfully analogous. So once we've proven two triangles are similar, we can show that the ratio of the corresponding sides are proportional, and we can show that the corresponding angles are congruent by two, I guess they're theorems, although as though they're not presented that way in the book, but by two principles that are covered in tonight's video. I'd also like you to take a look in the book at pages 346 and 347 because some of the examples presented there will be helpful for you in doing the exercises. Okay, I hope this video helps, and if you have any questions, we can answer them in class. Thanks for watching. Consider the diagram here, and it's maybe more difficult to see than some of the congruencies we worked with in the first semester. But you'll get used to recognizing that triangle ABC could be similar to triangle DEC. Now, just like in the first semester, the order really matters. So, if we were given that triangle ABC was similar to triangle DEC, we would know that angle A was equal to angle D because they occupied the first position in what's called the similarity statement. Angle B would be congruent to angle E because it occupies the second, they both occupy the second position in the similarity statement. And of course, angle C would be congruent to angle C because it occupies the third position in the similarity statement, but also because it's a reflexive angle. So, what is the reason for showing that angle A is congruent to angle EDC? Well, the reason is just going to be corresponding angles of similar triangles are congruent. I'll let you abbreviate that as CASTC. But be careful, on a quiz I may ask you what that abbreviation stands for. You'll recognize, I hope, that this is very similar to CPCTC, which we had in the first semester dealing with congruency. Alright, so corresponding angles of similar triangles are congruent. What then about the sides? Well, I hope we saw that the ratios of corresponding sides are congruent when the triangles are similar. So to prove that AB over DE is congruent to the ratio on the right, BC over EC, I'll give you the reasoning for that in a minute. But notice again how the importance of the similarity statement. AB is the segment occupying the first two positions of the similarity statement, and that corresponds to segment DE, which occupies the first two positions on the right. BC, the numerator on the second ratio, occupies the second and third positions, as EC, the denominator of the ratio on the right, occupies the second and third positions in the other triangle. Recognizing and using these similarity statements to help figure out the appropriate ratio is a very important skill to learn in this chapter. So, if I knew the two triangles were similar, how would I prove that these proportions are congruent? Well, it's very similar to the earlier proof. I can show that the ratio AB over DE is equal to the ratio BC over EC by corresponding sides of similar triangles are proportional. I'll let you abbreviate that as CSSTP, but again, be careful to make sure you know what the abbreviation means should it come up on a quiz or a test. Finally, sometimes this book goes one step further than that and asks us to show that the products of two sides of one triangle are equal to the product of two sides of another, or I should say, not of one triangle, but that these two products are congruent. Hopefully you recognize that these products are the result of cross-multiplying the ratio we saw above? If so, the justification that the products are equal is the means extremes product theorem. All right, once again, don't forget to look at the examples on page 346 and 347. They'll help you a lot with this. I think this is tricky stuff. It's much trickier than the congruence that we came across in the first semester. I want once again to point you to the importance of recognizing the order of the angles of these vertices mentioned in the similarity statement. They're the key to unlocking which angles are congruent and which segments are proportional. Okay, thanks for watching, Ramblers, and I hope this video helps.